Imagine lying in bed, eyes heavy, and wondering, what if time was not a river flowing forward, but an ocean we could swim through? Could we step into yesterday, or leap into tomorrow as easily as we drift into dreams? Tonight, let's wander into the sleepy science of time travel, a place where physics and imagination meet. Welcome, dear listener, to the Wandering Neuron, where we drift together through science, wonder, and the quiet mysteries of the universe. If you enjoy these journeys, where knowledge feels like a bedtime story, I invite you to gently subscribe so we can keep traveling, one sleepy question at a time. Close your eyes for a moment. Feel the quiet weight of your body resting against the earth, the gentle rhythm of your breath, the way your thoughts soften at the edges when night comes. In this stillness, time itself feels slower, almost drowsy, as though the ticking of the clock hesitates between each second. But what is this thing we call time? It slips through our fingers, yet rules every heartbeat and sunrise. The ancients imagined it as a wheel turning endlessly, or as an endless river carrying us forward. In physics, though, time is woven into the very fabric of the universe, inseparable from space itself, together forming what Einstein called space-time. To wonder about time travel, we first need to let time itself stretch out before us like a long and winding road, one that may not move only forward, but perhaps loops, bends, and folds upon itself in ways we cannot yet fully see. And so, tonight, as you drift toward sleep, let's walk quietly into this road and see whether the universe allows us to step beyond the present. If you have ever sat on a train and watched the world pass by, you may have noticed something strange. The people outside see you moving, while to you, sitting comfortably in your seat, it feels like you are still. Which version is true? Physics tells us both are. Einstein, in his theory of relativity, revealed that motion and time are deeply connected. Time does not flow at the same rate for everyone. It bends with speed, with gravity, with the very conditions of the cosmos. Imagine two twins. One remains on Earth, while the other sails into space at nearly the speed of light. When the traveler returns, less time has passed for them than for their sibling on Earth. This is not fantasy. It is a real consequence of relativity, confirmed by experiments with atomic clocks flown on airplanes. Time, it seems, can sleep more slowly or more quickly, depending on where you are and how fast you travel. And so, in a sense, time travel into the future is already possible. Every astronaut aboard the International Space Station returns to Earth a tiny fraction of a second younger than they would have been, a sleepy gift from the universe, reminding us that the flow of time is not fixed. Now, picture yourself standing at the edge of a black hole, that mysterious darkness where gravity grows so strong that not even light can escape. To you, your watch ticks as normal, your heartbeat steady, your breath unchanged. But to someone far away, watching from the safety of distant space, your time would appear to slow and slow until it nearly stopped. This is gravitational time dilation, another dream of relativity. The deeper you are in a gravitational well, the closer you are to immense mass, the slower your time flows compared to someone far away. This isn't just theory. The global positioning system, the GPS that guides your phone, must account for these tiny differences in time between satellites in orbit and clocks on Earth's surface. Without adjusting for Einstein's sleepy distortions of time, your map would lead you astray. Here, we glimpse a strange truth. Time is not a universal rhythm, the same for all. It is a shifting melody, bending to speed and gravity. And if it bends, might it one day fold so completely that we could step into yesterday?
Close your eyes again and imagine time not as a single flowing stream, but as a river with many branches. To us, the surface of life feels like one direction, always forward. We are carried by the current, unable to turn back. But physics whispers that beneath the surface, there may be eddies, whirlpools, or hidden paths. Mathematicians call these possibilities closed time-like curves, loops in space-time, where an object could, in theory, return to its own past. Imagine walking down a forest path at night, only to find that every turn leads you back to the same clearing. Time, folding in on itself, might behave in the same way. The idea is not science fiction alone. In Einstein's equations, certain solutions allow for these loops. The universe, when twisted by immense mass or rotation, could create strange shortcuts through time. These are not proven, but they are not forbidden either, and that fact alone keeps physicists awake at night, even as we drift off to sleep. So we begin to wonder, if the future and past exist as pathways in the great fabric of space-time, are they waiting quietly for us, or are they forever sealed behind an invisible wall? Now let us imagine a tunnel. A tunnel not through earth or stone, but through the very fabric of space and time. These are what physicists call wormholes, theoretical passages connecting distant regions of the universe, or even different times. Picture space as a sheet of paper. If you draw two dots far apart, the distance seems vast. But if you fold the paper, those dots touch, and suddenly the journey between them is no longer impossible. That is the dream of a wormhole. Einstein and Nathan Rosen once described these bridges, and science fiction quickly embraced them as doorways to both galaxies and eras. Could we, in theory, step into a wormhole tonight and emerge in ancient Egypt? Or leap into the far future where Earth itself has changed beyond recognition? There is a sleepy catch. Wormholes, if they exist, would collapse almost instantly. To hold them open, some kind of exotic matter with negative energy would be required, something stranger than anything we have yet found. It is as though the universe teases us with a locked door, whispering that the key may exist, but hiding it deep within the mathematics. And still the thought lingers like a lullaby. Perhaps time travel is not about speed or machines, but about hidden corridors already folded into the cosmos, waiting for the right dreamer to walk through. Suppose for a moment that you could travel back. You step into yesterday, into last year, into centuries past. Would your footsteps alter the world, or would time resist your touch? This question gives rise to the grandfather paradox. If you journey into the past and change something essential, like preventing your own ancestors from meeting, would you erase your own existence? And if you did, who was it that traveled back in the first place? Physicists wrestle with this paradox like a restless sleeper tossing in the night. Some suggest that the universe would not allow contradictions, that events would always twist themselves into consistency. You might travel to the past, but everything you do would only ever lead to the same outcome you already know. Others imagine branching timelines, like a tree that grows a new limb each time a choice is made. In this view, your actions in the past create a parallel world, not a rewritten one. You would not erase yourself, you would simply wander into another dream of reality. And so the paradox remains like a whisper at the edge of consciousness. If time travel is possible, does it free us from destiny or prove that destiny is unbreakable? When people think of time travel, their minds often wander to machines, gleaming inventions with whirring gears, glowing portals, or quiet chairs surrounded by dials. The dream of a device that can lift us out of the present has filled stories for centuries, from H.G. Wells's The Time Machine to countless films that let us leap across history. But could a time machine exist, not just in imagination, but in physics? Some scientists have proposed designs, vast rotating cylinders of infinite length, or cosmic strings stretching through the universe that might bend time into loops. Others imagine harnessing wormholes with exotic matter, shaping them into controllable pathways.
Yet each design carries its sleepy obstacles. The energy required may be infinite, the materials beyond our reach, the stability fragile. It is as though the universe allows us to sketch the dream, but not to build it. Still, there is a strange beauty in this. The very act of imagining a time machine pulls us into deeper understanding of space-time, gravity, and quantum fields. Even if no machine is ever built, the dream itself expands our knowledge, a reminder that imagination is often the first engine of discovery. If relativity bends time on cosmic scales, quantum mechanics bends it at the tiniest. Here, in the realm of particles smaller than atoms, time becomes slippery, uncertain, and almost dreamlike. In quantum physics, particles can exist in multiple states at once. Some interpretations even suggest they can move both forward and backward in time, like whispers echoing before the sound is made. Richard Feynman once described antimatter as ordinary matter traveling backward through time, a thought both scientific and poetic. Then there are experiments with quantum entanglement, where two particles remain mysteriously linked across space. When one changes, the other seems to know instantly, no matter the distance. Some physicists have wondered, is this communication faster than light, or is time itself playing tricks we do not yet understand? At this scale, the line between past and future blurs. Cause and effect seem less certain, as though time itself is only a convenient story we tell about events. The sleepy lesson from quantum mechanics is this: perhaps time is not a rigid arrow at all, but a fragile mist shaped by how we look at it. It may feel strange to realize this, but you are already a time traveler. Every second that passes, you drift into the future, carried effortlessly by the ticking of your cells and the turning of the Earth. But more than that, relativity shows us that traveling into the future faster than those around you is possible. Astronauts orbiting Earth age ever so slightly slower than those below. Jets carrying atomic clocks return with tiny differences in their readings. The future is not some distant dream. It is already unfolding in different rhythms, depending on where you are. Think of your dreams. When you sleep, minutes in waking life may stretch into hours in dream time. Your mind drifts into futures and pasts that never happened, yet feel real. In a way, every dream is a rehearsal for time travel, a reminder that our perception of time is malleable, elastic, and deeply tied to the stories we tell ourselves. So, when we ask, is time travel possible, the answer may be softer than we expect. We are already doing it, slowly,
gently, every day. The universe has built us into its clockwork, and our lives are the ticking hands moving through the grand face of time. If you place a cup on the table and watch it fall, it shatters into pieces. But if I showed you the shards flying together, perfectly reforming into a cup, you'd know instantly that something was wrong. Why? Because time, for us, has an arrow. It points one way. This arrow is tied to entropy, the gradual increase of disorder in the universe. The past is always more ordered than the present, and the present more ordered than the future. Your memories exist because your brain records information in this one direction. We cannot remember tomorrow because tomorrow has not yet unfolded into disorder. But physics itself, the deep equations of relativity and quantum mechanics, do not demand this arrow. At the most fundamental level, time could run both ways. The arrow is born not of the laws themselves, but of the conditions of the universe. A great beginning where order was high, and entropy had only one way to grow. So perhaps the reason we cannot slip backward is not that the universe forbids it, but because the arrow we follow has been carved by the cosmos itself. We are dreamers, floating on entropy's current, forever moving into the unknown. Think for a moment about your own memories. They are fragments of the past, stitched together by your brain into a story that feels seamless. Yet neuroscience tells us memory is not a perfect recording. It is a reconstruction, shifting and reshaping each time you recall it. In this sense, your mind is already a time machine. Each night, in dreams, you leap between childhood and distant futures that never happened. Each day, in thought, you revisit moments long gone and imagine paths ahead. You are never fixed only in the present. You are constantly wandering through the corridors of your own timeline. Philosophers have even suggested that consciousness itself is a form of time travel. To be aware is to project yourself a moment ahead, to anticipate, to expect, to be prepared. The sleepy gift of the mind is that it lets us drift not only through space, but through the flow of time itself. So when we ask whether time travel is possible, perhaps the truest answer is that it is already happening within us, quietly, in every memory and every dream. Some cosmologists wonder if time is not a straight line at all, but a cycle. Just as seasons return, just as night follows day, the universe itself may rise, fall, and rise again. One idea is the Big Bounce, that our universe began not with a singular Big Bang, but with the collapse of a previous universe, bouncing outward into ours. If true, then time may be eternal, looping in great arcs of expansion and contraction, creation and return. In such a universe, the future is not an unexplored land, but a returning season. Everything that has happened may one day happen again, not in the same way, but as echoes, ripples, familiar patterns repeating in new forms. It is a sleepy thought. Perhaps time travel is not about leaping across centuries, but about recognizing that we are part of a rhythm larger than ourselves, a cosmic heartbeat, where every beginning is born from an ending. Beneath your feet lies an archive of time. Every rock layer, every fossilized leaf, every imprint of a long-vanished creature is a page in the universe's diary. To study geology or paleontology is to travel backward, not with machines, but with patience. When we hold a fossil shell in our hand, we are touching something that lived millions of years ago. That small spiral once cradled a living being, feeling the waves of an ancient sea. In this way, the Earth itself is a time machine, preserving echoes that allow us to walk among vanished worlds. The sleepy truth is that time travel is not always about moving our bodies through the ages. Sometimes it is about listening, letting the stones, the ice, and the stars whisper their ancient stories to us. Why does time travel capture us so deeply? Why do we dream of going back? Perhaps it is because we feel the weight of time in our own lives. Moments lost, words unsaid, choices that drifted away. To travel back would be to heal regrets, to relive joy, to see once more the faces we miss. But there is another reason: curiosity. Just as we look to the stars to ask where we came from, we long to see how the great story unfolds. What will the Earth look like in 1,000 years? How will humanity grow? Are we destined to scatter among the stars or fade like forgotten constellations? Time travel is both science and yearning. It is physics, yes, but also poetry. It is the ache of memory and the thrill of possibility. When we speak of time machines, we are really speaking of our own hearts. There is another way to think of time travel we often overlook. Every invention, every song, every book is a message sent forward. When an author writes, their words are a bridge across decades. When a composer creates music, it drifts into futures they will never see.
You are already a time traveler when you plant a seed, tell a story, or pass down knowledge. You cannot return to the past, but you can reach into the future, shaping it with your choices, your kindness, your dreams. In this sense, the human race itself is a great time machine. We carry the wisdom of those before us, and we gift the unborn generations with what we create now. And so, perhaps the sleepiest truth of all is this: time travel does not require wormholes or impossible machines. It requires only memory, imagination, and love, the things we already carry within us. Look up at the night sky. The stars you see are not as they are now, but as they were long ago. Some of their light has traveled for hundreds, thousands, even millions of years to reach your eyes. In a way, stargazing is a form of time travel. Each photon is a messenger from the past, carrying a snapshot of an ancient moment. When you gaze at the Andromeda Galaxy, you see it as it was over 2 million years ago, before humans ever walked the Earth. This cosmic delay reminds us that time is vast, and that our present is stitched together from countless pasts. The universe is always whispering, "To see me is to travel backward, gently, at the speed of light." And when the stars themselves sleep, collapsing, exploding, becoming black holes, they fold entire futures into their depths, scattering elements that will one day become new worlds, new lives. Some scientists wonder, what if every choice creates a new universe? When you choose to walk left instead of right, another version of you walks the other path in another world. When you say yes, another you says no elsewhere. This is the many worlds interpretation of quantum mechanics. It suggests that time does not fork only once, but endlessly, weaving an infinite forest of possibilities. In this view, time travel might not mean revisiting our past, but slipping sideways into another version of it, one where history unfolded differently. Imagine lying in bed and dreaming of a different life. In many worlds, that dream might not be fantasy, but a shadow of another reality, one where your choices led elsewhere. Though unproven, the idea is strangely soothing. It means no moment is ever lost, only branching. Somewhere, in some quiet corner of existence, every possibility continues to unfold.
As tempting as these visions are, wormholes, loops, branching worlds, many physicists believe that time itself may have built-in protections against paradox. Stephen Hawking once proposed the chronology protection conjecture. The universe might forbid time travel into the past to avoid contradictions. Perhaps wormholes collapse before they can form loops. Perhaps the laws of physics conspire to prevent backward travel, the way a dream dissolves when you try too hard to control it. And yet, even if time resists us, that resistance carries a strange comfort. It means the present moment is precious. It means the lives we live are unique, not endlessly rewritten. It means that what we carry forward, our stories, our discoveries, our kindness, matters profoundly. Time may not let us return, but it always lets us create. And in creation, we move forward into futures that no one has yet seen. Close your eyes for a moment. Imagine you were dreaming, wandering through a forest that never existed, or meeting a friend who has long since passed away. In dreams, time bends without asking for permission. A single second can stretch into a lifetime, while an entire night can vanish in the blink of a thought. This is the paradox of time travel as experienced by the mind. We already live in small pockets where past and present blend, where futures are rehearsed, where timelines overlap. Psychologists suggest that dreams may act as simulations, tiny laboratories of the mind where possible futures are tested, where old memories are reshaped. So, could it be that we already travel through time, at least in the private theater of our own minds? The physicist Brian Greene once said, "The distinction between past, present, and future is only an illusion." And in dreams, we feel that truth deeply. When you wake, the forest vanishes, but the memory remains as real as any yesterday. Albert Einstein often used simple images to describe the deepest mysteries of time. Imagine two clocks, one resting safely on Earth, another flying through space at near the speed of light. To you, on Earth, both seem to tick together. But to an observer moving quickly, the clock in motion slows down. This is time dilation. And it's not just theory, it's been proven with precise atomic clocks flown on planes and satellites. Time really does pass differently depending on how you move or how close you are to gravity's pull. So the next time you look at the ticking of your bedside clock, imagine there are countless versions of now, unfolding differently depending on where you are in the universe. To a traveler orbiting a black hole, 1 second may stretch into centuries compared to Earth. To someone racing with light, moments collapse into stillness. Albert Einstein once fell asleep in his chair dreaming of riding a beam of light. Perhaps his dreams were the first whispers of time travel itself.
But here's the puzzle. If time travel were possible, what would it mean for our lives? If you could leap into the past and change something, would it unravel the present? If you could visit the future, would you return the same person? Physicists call these questions paradoxes. Could you meet your younger self? Could you prevent your own birth? Or does the universe have hidden rules that protect the timeline from collapsing? Some scientists suggest that time may not allow contradictions. If you travel backward, you might be free to walk through the streets of history, but never to alter its foundations. Others imagine parallel timelines, branching out like a forest, each choice a new path, each journey birthing a new world. And as you drift deeper into sleep, let this thought settle. Maybe we don't need machines to travel through time.
Maybe each moment, each dream, each choice is already a quiet step across unseen timelines. Close your eyes and imagine yourself walking backward through your own life. Not through a machine or a wormhole, but through memory itself. Every photograph you've ever taken, every birthday candle you've blown out, every summer afternoon spent in quiet, each is a time capsule, waiting patiently in the folds of your mind. Neuroscientists tell us that when you recall a memory, your brain doesn't simply retrieve it like a file, it rebuilds it. The neurons fire again, weaving the past into the present moment. In that sense, you are time traveling. Your brain is bending the arrow of time to make yesterday feel like today. This is why a single smell, a single song, or even the sight of a certain color can make us feel transported. A whiff of rain on dry earth can carry you back to childhood summers. A melody from years ago can summon an entire chapter of your life in a heartbeat. We do not need science fiction to walk in time. We carry the ability within us. The brain itself is the most intimate time machine we will ever know. As you drift towards sleep, your dreams quietly become their own theater of time travel. In dreams, time does not obey the clocks. An entire lifetime can pass in a moment, or a single second can feel like an eternity. Some dream researchers suggest that our minds rehearse possible futures while we sleep, simulating choices, playing with outcomes, weaving fragments of experience into predictions. Others believe that dreams act as repair crews for memory, stitching today into the long tapestry of your life. But beyond the science, there is a poetry to dreams that is impossible to ignore. In dreams, you can walk with those who are no longer here. You can return to a home that no longer exists. You can live inside the pages of time your waking body has left behind. Dreams remind us that time is not just a physical measurement, it is also a feeling. And in that sense, the dream world may be the softest kind of time travel we will ever experience. Now, as we widen our gaze from the mind to the universe itself, we see that time stretches with a patience beyond comprehension. Stars are born in clouds of dust, live for billions of years, and then collapse into silence. Galaxies spiral and drift, colliding slowly, weaving new patterns of starlight. When we speak of cosmic time, we are speaking of rivers so vast that human years are mere ripples upon the surface. To the stars, our entire history, the pyramids, the poems, the inventions, the revolutions, is but a blink. And yet we are here, tiny travelers, conscious for only a short while, trying to understand the great clockwork that surrounds us. It is humbling, but it is also beautiful. Because even though our time is short, we get to ask questions about infinity. Even though our candle flickers for only a moment, we are allowed to wonder what lies beyond the darkness. And maybe that is the truest form of time travel. Not machines, not wormholes, not paradoxes, but the simple fact that within the brief span of our lives, we can leap across centuries with thought alone. Our curiosity itself bends time, carrying us forward. So, dear listener, tonight we have drifted across clocks and stars, wandered through Einstein's relativity, and brushed against the edges of paradox. Perhaps time travel is not about building a machine, but about the journeys we already take, into memory, into imagination, into the quiet dreamscapes of sleep. And now, as you rest, let the ticking of time dissolve. There is no yesterday, no tomorrow, only this gentle moment unfolding endlessly. Goodbye, traveler of the mind, until we meet again, in another night, in another dream.